Hey, Year 12s, we're going to do question 5 here. An activity network is shown below and write down the critical path. So very similar to what we've been doing. Critical path, we know that this is based on the activities that have zero float time, essentially. So what can we see from the ESTs and LSTs here? We can see that if you went with option A, then activity D has a float time, so that can't be a critical path. It looks to me that B is 1, so B taking 9 units duration means that E has to start at 9 and also has a finishing time at 9 as well. And then you can see that moving to the next point from B, 9 plus 4 gives you 13. But notice here that you've got 13 and 14, so there's a float of 1 there. So that means G has a bit of giveaway, whilst F, on the other hand, so you can see that F doesn't have another extra amount. So going up ahead, you can see that F has to be a critical pathway because, again, it's 13 and 13. And then going to H, you can see it's 14, 14. This must be a critical activity. And then lastly, J is a critical activity there. What else can we see? That's about it, really. Everything else seems like it's a non-critical pathway. So if I were to answer this question, write down the critical path. It is B to E, activity F, and activity H, and then activity J. Those are the activities with a critical pathway. Okay, so none of those people there, when they start these activities, it has to be on point. They have to start exactly at 0, and it takes exactly the duration they predicted in order for them to finish the entire activity in 18, say, minutes or whatever, 18 days or whatever the unit duration is. Okay, now part B says write down the float times for all non-critical activities. So non-critical activities would then be, you've got A, you've got activity D, you've got activity G, you've got activity I, yes, oh, which one's I? And that's activity C. One of them, what is this? Where is I? Ah, I is from here to here. Yep. Got you. Okay. So activity I as well. So let's calculate this now. So we want to find the float times for all non-critical activities. We know that from here to here is a weight of 10. That makes sense. So again, going backwards, 11 minus 10, technically there should be a separate box for A where it starts at 0 and 11 take away 10 gives you 1. So clearly you've got a duration. The latest time that you can start is 1 and you got earliest starting time is 0. So clearly for float time for A, there's a 1 there. Okay, so that means they don't have to start exactly on time. They can start 1 unit afterwards and they would still make it on time so that the next activity can start. So the next activity, let's say activity float time for D, for D, this one is nice and easy as well, because in D, we can already see that the activity D, its latest starting time is 11 and earliest starting time is 10. So clearly they have a float of 1 as well. Okay, so we can see that float for D is going to be 1. And then what else is there? There's G. So G has 13 and 14 there. And if we had a look at it again, so 13, 14, float for G, 13 and 14 clearly has a float of 1. 14 minus 13 gives you that leeway. So they don't have to start exactly 13. They can start at 14, which gives them a float time of 1. We've got I. So I, on the other hand, again, 14 and 15. So that implies that the duration, to take it all into account, there's a float time of 1 as well again. And if you're ever getting confused by this, like another way of thinking about it is you can say that the latest start time is 17. So whatever I does, it can only finish at it has to finish at 17. That's the latest time, right? So 17, if you minus the 2, which is the duration, that tells me that it's 15, right? So 17 minus the 15 gives you the 2, and then and you can see then 17 minus the 14, you get the 3, and the 3 minus 2 gives you that 1 distance. So if you're a bit confused here, so earlier start time, they can start at 17. If you minus this from the earlier start time, that tells you there's 3, right? So there's 3 units between I from the start to the end, but it only takes a duration of 2, so 3 minus 2 is also equal to 1. So you can think of it as the latest start time for J compared to the earliest start time for I. What's the amount of units in between, and minus duration could be a formula for you to work with, if that helps. Okay, so you always take LST of the next activity minus the EST of the previous activity minus the duration of that activity. That should tell you the float time. Okay, but I'm just doing it through logic at the moment, and so I know that I had to be a float time of 1. And then we've got float time of C. So let's have a look at C. So C says they can start at 3. Oh, sorry, duration of 3. But remember, you're starting off at 0. So that means 17 minus 3 gives me 14. It's got 0 to 14 units in between, and the latest start time clearly is 14. So 14 plus 3 will still make it on time at 17. So it's got a float time of 14 there. You got some 0 to 14. That tells me a float time of 14 in order to make sure that you can still complete the entire task. So that's how I would do the float time. You can probably understand in a different way, but that's how I would have done question 5.